All right. Okay, good. So let p equals xy be a point on the graph of y equals x squared minus 7. Express the distance d from p to the origin as a function of x. Okay, what are they talking about? These are hard for most people, but they're not that bad, I think, once you've seen me do a couple of them. Basically, let me give you the big idea first off, and then I'll get down to the details. So the big idea of what they're saying is they're talking about the function y equals x squared minus 7. Hey, you guys now, I'm just going to say, well, let me show you what the graph is, but I realize you guys know graphing now. We just had it, so you tell me. This is where already we'll see the benefits of being a good grapher. If you just look at x squared minus 7, what does that thing generally look like? What kind of shape is it? It's a U-shape, parabola. And what's the minus 7 going to do to it? Normally the parabola is centered at the origin, right? But where's it going to go with that? Left 7, right 7, up 7, down 7? Down 7. If it was in the parentheses, it would be the right-left thing, huh? But when it's outside the parentheses, it's the up-down thing, huh? So that's a parabola down 7. See how much you're learning already? Maybe you already knew that before you started the class. All right, so parabola. So generally it's something like that, right? That's generally what they're talking about. Some parabola down 7. Okay, now, they're saying let p equals xy be a point on the graph. So, it's just some kind of point. Call it right there. I don't know where it is. It's xy, some point on the graph. Express the distance d from that point P, this is called point P, to the origin. Origin's here. That's the origin, 0, 0. And they want me to write a formula for the distance between those. Does that make sense? So that's what we're trying to find. At some point P, what's the distance to the origin? Find a formula for the distance to the origin. All right. So now we say, all right, what is the distance formula? Does anybody remember it from your algebra days?
Square root of x.
Square root of x1 minus x2 squared plus y1 minus y2 squared. It's kind of like the slope formula, except they're in parentheses squared, and then they're added, and they're rooted. Where's that thing come from? I don't like to give formulas without reasons. Real quick, I don't have too much time to waste on this, but basically if you did a little right triangle right here, yeah, you could do a little Pythagorean theorem. That distance is the hypotenuse of a right triangle. This distance here, the sideways distance, is, right, this is the point, call this point x1, y1, and call this point x2, y, it's supposed to be a y there, x2, y2. Basically, the horizontal distance up here is the second x value minus the first x value, right? It's the difference of x values. And the vertical distance right here is the y2 minus the y1. So basically, if you say this squared plus that squared equals distance squared, right? x2 minus x1 squared plus y2 minus y1 squared equals distance squared. Whoops, that's off the screen. That screen always bugs me. All right. Distance squared, right? That's Pythagorean theorem. A squared plus b squared is c squared when you have a right triangle, right? And so then how do you solve for distance? Root it. There's the distance formula. That's where it comes from. So anyway, you don't have to do that or anything. You can just put this on your 3x5 card for the test Wednesday, Thursday, along with everything else we've covered, as I've said. All right, so there's the distance formula. So now let's just plug in our points. What's our point? One of them is 0, 0. The other one we're just calling xy, huh? So it doesn't matter which one you call x1, y1, which one's x2. I'll just say, okay, you're x1, y1, you're x2, y2. So, all right, what do we have? 0 minus x squared plus 0 minus y squared. That's just a fancy way to say root of x squared plus y squared, right? You with me? So far, so good. Those negatives vanish because a negative squared is, right? 0 minus x is just negative x. Squared is just x squared, right? We good to there? And what does that equal? Square root of x squared plus y squared equals? Just x plus y. Just root the x, root the y. No, that's wrong. But I see that all the time. You guys are supposed to stop me. I'm testing you constantly. Right? You're supposed to go, no, Mr. Heron. But don't do that when I'm right. But just when I'm doing crazy stuff. Right? Do you know that's not true? You need to. You need to. It's okay for now. It's not bad if you don't know that right now. It's bad if you don't know that next semester and you're trying to take calculus. You'll have endless troubles. This is what makes people fail calculus. All this little bitty stuff that they're not clear on. Algebra rules. You've got to be really solid. This is not true. If this was times, you could totally do it. Plus, in general, I always teach my algebra students, pluses and minuses wreck all the nice rules in algebra. It's just a good thing to have in the back of your mind. Anytime things are added or subtracted, anything nice, forget it. It never works. And that was times. That was time. That's where times was. You could totally do that. You could totally do it. It's all about pluses and minuses. You can prove it with numbers. We don't got time. So anyway, don't do that. Don't do that. I see that all the time. Just remember, I always tell them pluses or minuses are like glue. It's like they glue things together. Kind of stuck them together, and you can't do anything with it. Anyway, all right, onward we go from there. So there's our formula. Except, let me erase because I kind of wrote all over everything here. I'm there except, well, I'm circling too much. Except for those last little words. As a function of x. What does that mean? They don't want y in there. Like no y, just x. So I got to do something about that. I've got the answer, but I got x and y in there. So what do I do? I would like to sub in for y somehow. What could I possibly do? Yeah, right there. Y equals x squared minus 7. Right, why? Because y is on this parabola, and whenever you're on the parabola, your y coordinate is equal to your x coordinate squared minus 7. That's what it means to be on that parabola. If you're a dot on that parabola, your y coordinate equals your x coordinate squared minus 7. So that y squared is x squared minus 7 squared. Does that make sense? So I just plugged that right in there for y. Now I suppose we have to FOIL that out and gather like terms and do some nice stuff. On the test, I'm fine if you just want to leave it like that. That's the answer. Let's go to the next page and I'll clean that up like they probably want me to do. So distance, I'll flash back if you didn't get that, is x squared plus, what was x squared minus, well, I'm flash back already. X squared minus 7, quantity squared, right here. So x squared minus 7, quantity squared. So let's see, x squared, and then just write 2 of them. Right, you gotta do it that way, and then that's x squared, and then FOIL. So that x to the 4th minus 7x squared minus 7x squared plus 49, like that. And I'll put the most powerful one first, x to the 4th. X squared minus what, 14 is minus 13x squared plus 49. There's the answer they want. There's the distance formula as a function of x only. We got it. Is that good? So let's go back again to the first page and see what we did, because I think you can do all that algebra right there pretty easily. So what did I do again? I just said, look, okay, they want origin and point xy. You didn't need to draw all this picture stuff. This was not required. On the test, you would just say, look, I've got 2 points. I've got 0, 0, origin, and I've got some point xy, right? And then I just plug those into the distance formula, 0 minus x, 0 minus y squared, with a root over it. And then that's root of x squared plus y squared, and then plug in right here for y squared. And then just do the algebra. Make sense? That'll be a formula for distance. Oh, there's 3 parts remaining. Okay. So let's go. There's more to come. But wait, there is more. All right, so let's go. So if you take out your graphing calculator, we have that distance formula. Let me put it here for us. Okay, so the distance formula, it's right there on the screen. Nice. So I'll write it up here again, though. Yeah, the distance formula is the square root of x to the 4th minus 13x squared plus 49. Okay, so now what they want us to do is they want a smallest. Smallest means minimum, doesn't it? So you want to graph and find the minimum. So basically you want to graph that function, put it into y1, so put y1 equals the square root of x to the fourth minus 13x squared plus 49. Graph the thing and find the minimum value. That's what they want. Round your answer to 2 places. So let's do that. All right, so we've got x equals 2.55 and y equals 2.60 rounded to 2 places, as they said. So we'd enter, and that's all. So they just want the x, 2.55, and we're done. In a minute, and I might run out of time, so let me just say it right now. They might have another question where they ask you, what is the distance? So let me just cover it right now. What if they had said, give me the x. Boom, there's the x. We got that. That's clear. What is the distance? Because remember what we're doing. Let me keep the big picture before your eyes. We're finding the point along this curve that has minimum distance, closest to the, where do you think it is? I think it's probably about right here, that has the closest distance to the origin. So I bet it's right around the middle here. I don't know, but or what answer we get? We got x's, yeah, 2 something. Yeah, so that looks like it's maybe 2 something. I don't know. I can't tell. 1, 2. There, see, it's 2. But it looks like 2 something. So my point is, we're finding the point closest to the origin along this U shape, right? And there's going to be the same point on the other side, huh? That's that other minimum. There's really 2 of them. So, anyways, that's what we're finding is we're finding that point, and that x value, 2.55 we just got, that is the coordinates, that's the x coordinate, I should say, of that point. But the y, 2.60, is that what the y was, is not the y coordinate of that point. Did you hear that? That's what confuses people. They think, what do you mean? The x and the y, or the x and y are the point? The x is the x, the y is not the y. The y is distance. The y is distance, right? What did I enter? I entered the distance function. Remember, y is the function. Right? That's the part that confuses people. You guys catching me on that? Let's go back. Remember what we just entered. What is the y here? Distance. So the y, you got to always remember, what function am I putting in there? So the x is the x, the y is distance. In other words, on the U shape, that point is x 2.55. I don't know the y yet. I'll show you how to find it. But the distance is 2.60. How far that point is from the origin, right? Because this is a function for distance from the origin. Y equals the square root of x to the fourth, blah, blah, blah. That's a distance function we entered. So the y values, or the function values, are the distance values, right? So that's the distance. So if they ask you distance, that's that y. That's the 2.60 of the minimum point. Well, then how do you find, like, the y coordinate? Because sometimes they'll ask you that, too. How do you find, like, the y coordinate of that point? Plug in the x. Just take that 2.55 and plug it in. Where? To the original equation, y equals x squared minus 7. Right? Because that's the relationship between x and y values on the curve. Right? So if they ask you for the y value, the on curve y value, just remember y equals x squared minus 7. So take that x and plug it in. It's whatever 2.55 squared minus 7 is. Does that make sense then? Is everybody seeing that the original xy is actually x distance? And if they want the y coordinate, you got to plug the x into the original equation. Questions on that then? So we found the point that is on the curve, y equals x squared minus 7, the problem, that is closest to the origin. That's what we're able to do using the graphing calculator. Now, how do you know you need the graphing calculator? Well, they said use the graphing utility. But whenever we answer closest, furthest, biggest, smallest, we're using the graphing calculator. Have you noticed that? Those an English teacher would call those, I forgot the word, superlatives. That's what they're called. Right? You know, there's big, bigger, biggest. Right? Right? I don't know what the middle one's called. Bigger. What's that? There's a word for that. I don't know. I'm not an English teacher. But the biggest, the most extreme case, that's called the superlative. So smallest, biggest, furthest. Whenever they have the est at the end, you think, I need my graphing calculator. Because I'm maximizing or minimizing something. I'm finding the super case, the superlative case. That's when you need your graphing calculator. Next semester in calculus, you'll do it with calculus. You won't need a graphing calculator. All right, but for now, we use graphing calculator. Questions I can answer on that one? Are we good? Come on. All right. So this one's a little different. Right triangle has one vertex on the graph y equals x to the 6. This is y equals x to 6. X greater than 0 at xy. So that's xy. That vertex right there they're talking about. Okay. Another at the origin. And the other one at 0, y. Okay. So it makes a little triangle. Express the area of the triangle. Okay. So they're basically like making a triangle using a point on the U shape, right? They're saying, hey, and you know what they're going to do is they're going to let that vary. They're going to say, hey, take that U shape, and what if the point's way down here? You got that triangle. What if the point's way up there? You got that triangle. What if it's way up there? You got that triangle. They're going to start moving around on us is what they're going to do, right? All right. So anyway, let's answer. So they're kind of setting us up for doing all that. So let's play their game. They want us to find an area formula. All right. Well, that's the area of a triangle. What's the formula for the area? This is a triangle here, right? What's the area of a triangle? Half base height, right? All right, so we got a height and a base, don't we? All right. What's the base? You guys with me? So I'm looking at the triangle here. The area of any triangle is a half times the base times the height, right? Here's the base. How far is that? That's the x-coordinate, right? All right, whenever you have an xy coordinate, x is how far, right? It's how far from the origin over to that point, right? If you're here at the origin, how far, and you go into this point, x is how far from the origin to that point, horizontally. That's the base, isn't it? So the base is just x. And what's the height? It's y. The y is the height, isn't it? Whoops, it's supposed to be y. All right, so the height is y. Does that make sense there? Now, why is that not my answer? Function of x. They always want me to, in the end, they want me to get rid of the y. Every time they want you to get rid of the y. They just want x, because we can't enter into our calculator x and y, right? We're only going to put in x. It's y1 equals, and then just x that on. So we have to make it, we got to get rid of the y. How do we do that? Oh, there it is. There's the formula. Huh? Y equals x to the 6th. Pop that in for y. Same way. That's supposed to be a half there. And the y is x to the 6th. This was nicer, a little cleaner. There it is. There's the area function in terms of x. So you plug that in. Oh, that's all the parts. That's everything they want on that one. So that wasn't too bad. Is that okay? All right. I'm going to move on so I can... All right, so rectangle y equals 36 minus x squared. So that's that, 36 minus x squared. You guys know that. That's that upside down U shape, huh? Hits up at 36, because the same thing as minus x squared plus 36, isn't it? And so that's a U shape up, going down, but moved up 36, so which is that picture they have here. So there's the U shape. They have it right there. And what are they doing? They're wanting me to make a rectangle with it or something. They say... Another at the origin. Oh, yeah, so they're saying, okay, you got an XY point right there. Whoops, I'm in the wrong one. Right there. And you get the origin and make a rectangle, right? Isn't that what they're saying? Rectangle, one corner on the graph, another at the origin, a third on the positive Y. Yeah. Make a rectangle. There's a bunch of fancy talk for make a rectangle, right? So basically, make a rectangle from a dot on the U shape. And they're going to let it move along the U shape. You get the idea? So we have this U shape. They're going to go, what if the dot's way up here? Well, okay, then go straight over, straight down. They're saying basically go straight over, straight down, make a rectangle. Get the idea? Wherever. What if the dot's here? Go straight over, straight down, make a rectangle. And they're going to say, hey, what dot makes the biggest area rectangle? That's what they're going to do in a minute. Do you see how different dots, if you go straight over, straight down, make different rectangles? And what dot will make the biggest rectangle? Biggest. Super case. Superlative. Maximum. So basically the game plan here is get a function, go to our graphing calculator, find the maximum, right? That's the game plan. All right, so, calculus, you'll do these same problems, but you can find maximums with a derivative by hand without a calculator. For now, we need a calculator. So, how do we do that? Well, so I need, what do they want me? Oh, they want area of the rectangle. So what's the area of a rectangle? It's base times height. We don't need the half like we do for a triangle, because a triangle is half a rectangle, huh? So that was why we have the half in the triangle formula. But for rectangle, we just have base times height, or you call it length times width, or Joe and Tom. It's just names. It doesn't matter what you call it. Base and height, length and width, whatever. Two sides multiplied for the area of a rectangle. So what are the bases? We got a base here and a height there. So what's the base? That's just x again, right? Because that's how x is how far from the origin over. And the height is just y again, isn't it? And yeah, and then you know what to do. There's the y. Plug in. This is getting easy now, right? So x times 36 minus x squared. Distribute 36x minus x cubed. There's our formula. So that's going to be part 1. Part 2, they'll probably have you plug in 0 or 1 or something like that. And then part 3, they'll say find the maximum. So just put that into y1, graph it, find the max. We good? They have a couple tricky ones. I better get to those. All right. Okay. So same kind of thing. Oh no, this is a little tricky. Yeah, we're inscribing a circle. No, a rectangle is inscribed in a circle of radius 1. Okay, so basically they're saying, hey, take a circle of radius 1. That means this is over 1, this is back 1, this is up 1, this is down 1. Circle of radius 1. And they're saying, hey, put a rectangle in there. Well, there's all kinds of ways to put a rectangle in there, isn't there? In other words, you could put a rectangle in like this, like kind of a tall, thin one. Like that. Or you could do like a short, wide one. Inscribed, whenever one shape is inscribed, it means it's inside and the edges just hit right on the edges. The corners, I should say, the corners hit the edges. Like that. That's what inscribed means. Or you could do kind of a medium one. Which of those do you think is going to be, they're going to ask us which rectangle holds the most area. What's the rectangle you can fit in the circle that'll hold the most area? What do you think the answer is? What kind of rectangle is it? A square. It'll end up being a square. It's the medium one. It's the perfect square with length and width match. Huh? That'll be the answer. But let's go through and prove it. So that's what they're talking about. That's what they're doing on this problem. So let's go through and find our formulas. So they want the area of a rectangle. So you know area of a rectangle, length and width, or base height, whatever you want to call them. So width and length, or if that bugs you, maybe I'll do base and height, whatever. It really doesn't matter, but we're used to base and height, so we'll just stay with that. So base and height. So what's the base? Now be careful. What's the base of that rectangle? It's 2x, not x. So everybody's going to say why? Because what is x again? How far from the middle to the side? That's x. So the base is 2x. Right? Everybody good with that? Everybody good? Everybody see that? You got to know that. Got to be careful on that. That one little thing. That kind of matters. My daughter took Calc 1 last semester, and she put X. And they put this. Her teacher put this on. Her teacher here put that on a calc test. She forgot the 2, got 0 on the problem. So sometimes calculus teachers are tough. So make sure you understand that's 2x, not x, right? And then what's the height? It's going to be the same thing. Because y again, remember, x and y are always from the origin, aren't they? So y is from the origin up. So base height is 2y. So then area is 4. You can put those 2's together, right? They're just all multiplying. 2 times x times 2 times y. So 4xy. And then you know the deal? Well, no, actually, no, they didn't give me. There's no good deal here. I was looking for the y. We're going to have to think about the y. Yeah, so we need like a y equals something now so we can plug it in there, huh? And then the rest is regular. How are we going to do that?
We use the x squared plus y squared equals 1.
Oh, I didn't notice it. Yeah, that was very nice of them. They did give us that. Yes, good job. Yeah, so that's the it's the formula of the circle. That's for the coordinates around the circle. So yeah, just solve that for y. Subtract x squared from both sides, and then root it. There it is. Y equals the root of 1 minus x squared. So bring that over, plug it in for x root 1 minus there's your formula. The rest is the same. They're going to have you plug that in, find the maximum, and it turns out it'll be a square. Is everybody okay with that one? So again, base times height, 2x, 2y. 4xy, and then we get the formula and solve for y. Plug it in. I do believe this is the one where they ask you both like x, y, and distance, or not distance, area on this one. So that's where you got to remember, when you enter this to your calculator, this will be the y at first, right? Y is the function. So the x, when you do the math, and you graph it, you get a graph, and you find the maximum, that maximum will be x area. Not really xy, x area, right? Because the y values are area values, right? So it's x area, and then to find the actual y coordinate, you have to enter into the function here, your x. Plug into y equals square root of 1 minus x squared, like we talked about earlier on number 1. Is that good? Questions there? All right, and I wish all these sections had 6 problems. I could get them all done in one lecture easily. All right, so there we go. Big old box thing. An open box with a square base. Maybe we'll do this one all the way through. We have 10 minutes. An open box with a square base is to be made from a square piece of cardboard, 18 inches on the side, by cutting into a square. You can see in the picture what they're talking about, right? They're basically going to take a flat piece of cardboard and then cut out 4 little squares, one from each corner, and then fold it up into be a box. It'll have no top, right? Yeah, I guess it's got no top. But we're just going to talk about the volume of the box. So basically the question is, how would a company take a piece of cardboard, cut out the corners, fold it into a box in a way that will hold the most volume possible? That's what we're interested in doing. They're going to have to maximize volume in this. Right? There's different ways to do it, depending on how you cut those corners out. You can make a box that's kind of short and wide, not very tall, but big base, or small, or really tiny base and super tall, or somewhere in between, which is always the best for maximizing space. Is make something with kind of a medium base and a medium height, right? That's what it's going to turn out to be. What's it going to turn out to be? What's the box of maximum volume going to be? It's going to be a cube, we call it. Yeah, it's going to be perfectly cubic, isn't it? It's going to be the same dimensions, I think. I might be missing something. We'll see. All right, so let's give it a go. So this is a little tricky. So we have to find a formula for the volume. And who would be interested in this? Anyways, is this real life? Is there any companies you know that look to save money if they can use cardboard more cheaply to pack more from the same piece of cardboard? Yeah, the companies that are taking over the world. Who's taking over the world? And I don't know if you're like me. Yeah, I order things through Amazon, and it's so darn convenient. And so FedEx is taking over the world, right? FedEx and UPS, the delivery people. I mean, that's the way to go, right? So delivery companies would be hugely benefited, right? And that's what they do. They hire people. They hire people that can do this kind of stuff to solve for them and tell them, okay, do this with your boxes, do that with your boxes. They can save $1 on every box. So what do they do a day? 10 million boxes or something? That's dollars to them, right? If they can pack more for the same amount of cardboard, it's dollars to them. So this is what real life goes on. Okay, so let's solve it. So volume. Now, what's the volume? It's just length times width times height, right? For a big cubic thing. Volume of a box. Everybody okay with that? Just length times width is the base times the height. That'll be how much a cube holds. Are you okay? I'm hoping you're okay with that. Right? If you have a length, a width, and a height like that. So that's how much the box holds. So how do we find the length and the width and the height? Well, can you picture the picture over here? It's this is 18 total. Can you see that okay? It's kind of small, huh? 18 from edge. The original was 18 from edge to edge. And same thing here, 18 edge to edge. Okay? But we're going to cut out a little X piece and a little X piece. So therefore, how far from here to here? 18 minus 2x. Everybody see that? 18 minus 2x. Right? Because these two corners are x. We're taking out x, taking out x. So it's full width, 18, take away the two x's. Right? Is going to be, and that's going to be the width or the length, or whatever you want to call it. That's going to be one of our dimensions, 18 minus 2x. The other one's going to be the same thing, right? Because we're going to take out the, over here it's going to do the same exact thing. We're going to take out the x and take out the x, right? Take out the x, take out the x. So this will be, again, 18 minus 2x from here to here, right? You see all that scribbles? So that's, this one's also 18 minus 2x. And what's the height of the box? It's going to be x. Because the height will just be that x. Maybe I should clear up the picture a little bit. Whatever you call them, it doesn't matter. You turn the box, the length becomes the width, becomes the height, whatever. I'm just saying the way it's sitting flat, this little piece right here will fold up and become x height, won't it? Do you see that? Everybody okay with that? That little piece will fold up and become the height. So x is the height. So our three dimensions then are 18, so the volume is 18 minus 2x, 18 minus 2x, and x. Any order, you put those in any order. We just got to FOIL them all out now. Right? All right, so FOIL. So 8 times 18. I don't know that one. Somebody got it? 300 something. 324, thank you. 324 minus 36x minus 36x plus 4. So I just left the x sitting out there while I FOILed. Come up here. So volume is 324 minus 72x plus 4x squared. Oh, I'm probably off the screen. Almost. X is sitting out there. Now, that x goes boom, boom, boom. 324x minus 72x squared plus 4x cubed. There's our volume. And we've already got it just with x. We don't have to do any y plug-in or anything, huh? It's kind of nice. So there's the volume formula in terms of x. That means depending on what you choose x to be, which is how much of a square you're cutting out of the corner, there's how much volume you're going to get. It's kind of interesting, huh? You say, I want to cut out 1 inch, a 1 inch by 1 inch square. X is 1. Plug in 1. It'll tell you how much volume you're going to get out of that box. I want 2 inches cut out of the corners. Plug in 2 for x, it'll tell you how much volume you're going to get out of the box if you cut it 2 inch by 2 inch squares out of the corner. Is that good? You got 4 minutes. See if we can answer all the questions. All right, so now we're going to enter this to our calculator. So let's enter that to your calculator. So, it's off the screen though, huh? So, all right, so you guys got that in. Put that in Y1 and graph it. See what you get. I'm going to go back and see what the picture, what it was. What was it? 324 x minus 72x squared plus 4x cubed to the third. And then just graph the thing. And all right, so graph the thing. Okay, I got something way over to the right, like that. Did you guys get that? That's weird looking. I thought we were trying to find maximum. That looks totally bizarre. So I'm going to go to table. I don't know what's going on. Second table. Oh, look, my y values are like super high. See how this is helping me? My y values are way up there. Like, what's the biggest one? What's the biggest y value? 432. Yeah, so I need to go up to like 450 on the y. See how I need to do that? And there's no negative, so I can just go 0 to 450, and that'll cover the y's, right? That makes sense? See how the table's helping me a lot? Right? I just hit second table. After the graph, I got a weird-looking graph. I just hit second table, and I go, oh, that's the problem. Because I'm supposed to have y's going up to about 450. So go back to your window. X, I don't need negatives on the x. X is 0. I'll just do 0 to 10. Y, 0 to 450. Go back to graph now. Much nicer. See how easy that was? Just hit second table, and that shows you where your y values are. Make x 0 to 10 and y 0 to 450. Now they're going to want me to find that maximum. So you know what to do, right? Just hit second max, and we will find it. Or second calc, second calc. Go down to max. Go left of it, right of it. So this is 0 to 450 on my y window. Left of it, right of it, and then go kind of on it. Enter. There we go. 2 point, looks like 2. Or 3. Is that 3? Yeah, 3. Point a bunch of O's. That's 3. The calculator just runs numbers fast. That's the best it can do. Y is 432. So Y is 432. X is 3. X is 3. So we got the answer. X is 3. Y is 432. What was our graph? Was it was it this one? It looks like it's D, and then they'll say what's the, I don't know what they'll ask you. What's the X value? What's the total volume? This is volume. Remember, Y values are volume. They're the function. Yeah. All right, we have finished. We finished them all.